So, all throughout your life, even when you've been little babies like this dude here, you guys have been taught math by using what we call the infix method. I'm sure that many of you know what this method is. It's where you normally have the following. You have an operand, like the number 4. You then have an operator, like plus. You have another operand, and it'll normally result. This is called the infix method. It's what we used to do. To be using, shall I say. However, computers, believe it or not, don't like processing like this. So what we could use is something called reverse Polish notation. What does that mean? Well, it's basically what we call postfix. So basically, it allows the machine to interpret our expression in a way which it can understand. So what does it look like? Well, instead of doing 4 plus 3 equals 7, we're going to do 4, 3 plus. So all we've done, we've got an operand, and we've grouped it together, and the operator is done afterwards. Okay, so what's the benefit of using RPN, which is reverse Polish notation? Well, it basically doesn't actually need brackets. When we do infix, we could use brackets, etc., especially for more complicated sums. But when we use RPN, we don't need to use brackets. So that's a nice advantage for using this method. Another advantage is that it doesn't actually take into account rules of precedence. So it doesn't actually need to know about rules of precedence when it's being used. So that basically means that obviously multiply is worth more than a plus, and that multiply is worth more than a minus, and that multiply is worth more than brackets, etc. We use that as a part of a conversion method, but RPN doesn't actually really care about precedence. And it's easy to use with RPN because it always evaluates, finally, from left to right. So we're always going in this direction. So it's easy to use. So far I want you to take away the following. We've got infix, which is our traditional method of doing math. We've got postfix, which is reverse Polish notation. And the difference is we put the operand first, followed by the operator. Why do we use reverse Polish notation? Well, basically to help the machines interpret expressions such as this. There are other methods which could be used, but RPN has some advantages that it doesn't need brackets, it doesn't take into account precedence, and it's easy to evaluate expressions because it goes from left to right. Let's get on to some actual A-level questions. So, excuse me, we've got an infix expression here. This is infix. And we need to turn it into RPN. So how do we go about doing this? Well, the best way to use RPN is to group our operands into pairs. Luckily enough, this is done naturally for us already, where we've got the A plus B, and we've got the C minus D, and then we've obviously got this multiplication. So before we can do this multiplication, we need to work out the expression of A plus B. So if we were to write this out in RPN, give it a go now yourself. Pause the video, try it out. How do you turn A plus B into RPN? Okay, what you should have got would be A, B, plus. So that is done already. Now, before we can use the multiplication, we need to work out the value of C minus D. So again, turn C minus D into RPN for me. Pause the video. Okay, so what you should have got was C, D, minus. So we've done this. That just leaves us with this multiplication. So we just add that to the end. Ta-da! We've just done the reverse Polish notation for this expression. Nice and simple, 2 out of 2. Let's make it slightly harder. So, an easy rule to remember when you're working this out is that I said before we need to pair these up. So, let's do them in different colours. We've obviously got a pair here. We've quite naturally got a pair here. However, we don't seem to have a pair here. It's just a single operand. So, something minus a, well, there's nothing here, may as well just be a 0. It's the same thing. So I'm going to group that up as a pair. That's my step 1. Now I'm going to deal with these as individuals. So if I bring this down, 0 take away minus a is the same as saying minus a. But if we're using RPN, it would be a minus. Now, I'm going to go to this bracket first. C minus D. It's the same as saying CD minus. Okay. Now, we've also got B multiplied by 4. But I'm not going to touch this yet. What I am going to do is have a look at this new group. Oops. Because remember, we always go left to right. So let me just make this a bit better. So we've got A divided by B. So the way we'll write this out would be B, and then move the divide sign to this side. That leaves us with B multiplied by 4. So it would be, we can use the 4 and then multiply, because we move the operator, and that just leaves us with all of this, and this bracket here, and this is the connecting operator, and as it's the connecting operator, we'll move it here. So to write this out, it would be A minus B divided by 4 multiply C D minus divide. Okay, so we've had some exposure of turning infix into postfix. Now, what we need to look at now is some alternative questions to do with RPN. So what we have is an actual question which is basically describing how the computer actually converts infix to RPN. So what we have is we've got the interpreter. We've got some variables, W, X, Y, and Z. The program contains an expression written in infix form. The interpreter converts this infix expression to RPN. The RPN expression is going to be this. The interpreter will evaluate this RPN expression using a stack. Now, if you remember what a stack is, it's going to be first in, F in, and the last one out. So whatever item's recent will come out first. The interpreter evaluates this expression using a stack. This is the data. Now, so we've got X, which is actually 2, and it goes into the stack like that. It wants us to actually show how the stack works with evaluating this expression. So it's basically saying, become an interpreter. Your brain is now going to be working as an interpreter using a stack. How does it work? Well, we've got our 2, and the next number is W being 1. So we've still got a 2 in there, and we've got a 1 in there. Really simple. So we've done this. We've done this. We've now got Z, which is worth 4. So we've got 2, 1, 4. Simple. Uh-oh, we've now got an operator, a plus. What do we do? This is a rule every time for any type of operator. We take the 2 most recent items put into the stack, and we then use the operator between them. So in this case, we've got the 4, we've got a 1, and the operator being a plus. The result of that is going to be a 5. So in our stack, we're going to have a 2, and we're going to have a 5. Okay, so we've done that. We've now got Y, which is worth 3. So we've got 2, 5, 3. We've now got an operator. So what we're going to have is 3, 5, minus, answer being 2. So we take these 2 out, remember. We use this operator, which is now gone. So our stack has 2, and it has 2. The last thing we've got is a multiply. So 2 multiplied by 2 equals 4. And there we go. Okay, so this method is going to be the same every time we do this as well. So we're converting back to infix. To do that, what we're going to do is we're going to move along the expression we've got until we've got 2 operands followed by an operator. So we've got an operand, but we've got another operand, so this doesn't work. We've then got operand, operator. So we've got W, we've got Z, and we've got the operator. And I'm going to give it a letter which isn't in here, so I'm going to give it the letter N, just for now. So I'm going to write this expression out again. We've got X, and we've got N. Whenever I talk about N, I'm actually talking about W plus Z. So we've done this, done this, done this. We've now got Y. So we've got Y, and we've got N. And we've got a minus sign. So we're going to do N minus Y. I'm going to give it another letter, O. Make sure the letter's not in there so we're not going to get confused. O. So we've done that, and we've done that. That leaves us with this, and I'm going to use this and move it right here. So we're going to be left with, if I write all of this out as an expression, X multiplied by my first bracket, N. Remember, we've got N because of the W plus Z. So it's actually still going to be W plus Z. Oops, don't close bracket yet. We've then got O. So for O, we've got N, which is W plus Z, minus Y. So all I need to do is minus Y. And there you go. That is my expression. So the steps again, just one more time. What I did is I went along the line, the expression, until I got 2 operands followed by an operator. I wrote them out, W add Z, and I gave it a new letter, like a shortened expression, and I put it here. I then used this new expression to combine it because it's basically an operand, and we then, so we had N, which is basically this, Y, and a minus. So that became my new expression, remember, operand, operand, operator. And I set it to the letter 0, not 0, O. I wrote that down. Shifted the multiplier to the start, as it takes precedence in this form. So we've got x multiply w plus z minus y. So the n, remember, actually equates to that, and the O equates to basically the result of this, and y with a minus.